Okay, hi everyone. So this will be a review for chapter 6 revision quiz. So there are 20 questions, and based on your Google Form responses, the question we'll be discussing is question 2, question 6, question 10, question 11, and question 17. These 5 questions. So let's proceed to question number 2. Question 2. A coin of mass m is placed on a disk which is rotating about its vertical axis at constant angular velocity omega. Okay, so to describe the situation is, you will have a disk, and this disk is rotating about an vertical axis. So it's rotating around this axis with a constant angular velocity of omega. The coefficient of static friction between the coin and the surface of this is mu. Okay, as they say here, it's placed on the disk, so our coin will probably be around here. It's placed on the disk, so it's rotating along with the coin is rotating along with disk. So the angular velocity will be the same since it's rotating along with the disk. If the coin does not slip, the maximum distance between the coin and the center of the disk is okay. So this sentence is important. It provides us a lot of hints what should we do. First thing is does not slip. When we say does not slip, what it means here is we are talking about static friction. Okay? Does not slip means by there's no relative motion, so it should be static friction. And the second thing we should know is it involves maximum distance. So if we talk about maximum distance and we relate it to static friction, it will most probably be maximum static friction, which I think you might be able to recall it from chapter 4. The maximum static friction is Fs max, and it's equal to mu n, or to be more specific, mu s n. Okay, knowing that, we should be able to proceed with the question. As usual, any chapter 6 question, we start with a free body diagram. So a free body diagram, we start with a dot and an axis. So this one will be away and towards the center. This line here will be this line. And we will have one line which go through the plane of the disk. Okay, so let's try to label all the forces being exerted on this coin. We have our weight as usual, the weight of the coin, and we have the normal force exerted by the disk on the coin, normal force. Okay, there's no force being explicitly stated. There's no ropes, there's no cables, and because there's surface, we have normal. And since they say this is a surface with coefficient of static friction, we should know that there should be static friction pointing towards the center of the circle. In that case, this should be our free body diagram. We should keep note that the center is probably around here. Okay, so when we build our free body diagram, it should be something like this. When we build our equation, the sum of fx is this axis here, and we know it's towards and away from the center of the circle. So most probably it's equal to MAC, which is the mass times the centripetal acceleration. And we know that Fx is Fs max. In this particular situation, Fs max equals to MAC. And now we also know that from here, Fs max is basically just mu s n times MAC. Okay, probably when you reach here, you might be stuck, and you see that there's nothing with an n inside here, with a normal force. No answer here have an n inside it. So probably we need to substitute the n with something else. So how do you find what's representing n? We go for another axis. Sum of Fy equals to 0. In this case, if we see the free body diagram, we take what's up minus what's down. Okay, down minus up also can, but let's take up minus down. And this will be your equation for the y-axis. So you can move this around, then you get n equals to w. And since w is weight, you know it's equivalent to mg. Okay, so with that, we can bring this n and substitute it back here. So now we know that this will be equals to mu mg equals to m AC. Okay, they ask for the maximum distance and you need to express it in terms of omega. So let's change the centripetal acceleration to be expressed in mr omega squared. There's this thing that we want to find, and there's this thing in the answer. So this will be a more appropriate representation for centripetal acceleration. So with that, we can cancel out some stuff. The mass here and the mass here can be cancelled out. So what you are left here is mu g equals to r omega. We are looking for r, so we bring r to one side, everything to the other side, and there's your answer. R equals to mu g over omega squared. So the answer would be this. Okay, there's a bit of manipulation involved, but if you steadily go through all the algebraic manipulation, you will arrive at the answer for this question. Okay, let's move on to question number 6. Number 6 is also a similar question. It involves a coin which is on top of a turntable. Just now it's on the disc. This is the same thing as a turntable. So this is rotating with an angular velocity of omega. Okay, so you slowly increase the distance. This is a bit different from the previous question, so let me discuss this. You have your turntable, which is round shape, and you have your coin, okay, which is probably around here. Okay, what does it mean here is, if this is your center, what the question says is, you slowly increase the distance of the coin from the center. Slowly increase the distance of the coin from the center, and you let it rotate. You let it undergo circular motion along with the turntable. Okay, the coin is undergoing circular motion along with the turntable. So if the turntable has an angular velocity of omega, the coin will also have an angular velocity of omega. So the question says, when this distance is increased until a distance of r, then the coin will start to slide. Okay, means by it goes from static friction to kinetic friction. It starts to slide. Okay, so if the angular velocity is doubled, what is the distance of the coin from O, which is the center, when the coin starts to slide? Okay, so previously it was in omega. Okay, now the new angular velocity, omega prime, is equals to 2 times of the old omega. So what will be the new distance r prime for the coin to slide? This is what the question is asking for. Okay, we use back a bit of the things that we discussed in question 2, since they are basically the same question. Let's use back this particular formula. Okay, r equals to mu g over omega squared. Let's just copy the equation here, since if we do the same thing, it will be the same derivation as well. Okay, so this is the equation. For the old situation, this is the equation. For the new situation, the mu won't change because it's still the same coin, it's still the same turntable. The g won't change as well because that's acceleration due to gravity is always negative 9.81. In this case, it's 9.81, sorry, it's 9.81, and omega will be a new omega square. Okay, so now we ask what is the new distance expressed in terms of the old distance. So what we'll be doing is something like this. Since you want to express r prime in terms of r, so we do something like this. What we do is we put in everything. And what will come out is mu g over omega prime square, mu g omega square. So you come out with omega divided by omega prime square. And as you know here, the omega, new omega prime is 2 times of the old omega. So you can do a bit of a substitution here. Then you arrive at 1 over 2 square, which is basically 1 over 4. So since r prime over r is 1 over 4, the new r, the new distance, is 1 over 4 times of the old distance. And with that, we can conclude our answer is r over 4. Okay, question 10. Question 10 involves a mass at the end of the string, and it's moving in a vertical circle of radius r. Okay, the diagram uses a thick line for the circle, so probably if you usually do it, it's a string, a ball, and it's moving in vertical circular motion. Okay, so now which of the following is the correct expression for minimum angular velocity of the stone at the highest point P for it to complete the circle? If you remember from the tutorial in class, you know that the tension at the bottom will be greater than the tension at the top. Okay, we discussed this in the tutorial. Tension at the bottom will be greater than the tension at the top. Okay, so this question asks for the minimum angular velocity. Okay, so if the angular velocity goes below this minimum, what will happen is the ball can't complete the circle. Once it reaches the top, it will fall towards the center. That's what happens if your angular velocity is less than the minimum angular velocity. Okay, so if it falls, means by the string is not tight anymore. So when the string is not tight, the tension at the top will be equals to 0 if the ball falls at the top. Okay, so we ask for the minimum angular speed, which is the minimum angular velocity you need so that the ball almost want to fall but not fall, almost want to fall, not fall, then get over a complete circle. In that case, we will use this particular thing here. Okay, this is the condition that we're looking for. When t top is equal to 0, what is the minimum angular velocity? Okay, so as usual, chapter 6, let's start with a free body diagram. So the free body diagram at the top, the free body diagram will be there's weight of the ball and there's tension top. Okay, so if you do the equation, maybe sum of f in the y direction is equals to MAC, and now we know there's weight and t top involved in order to get MAC. They are in the same direction towards the center of the circle. The acceleration, centripetal acceleration, is in this direction, so we add these two things up. Okay, so now once we reach here, we use the condition that we say just now. The t top must be 0. So now it will be weight equals to MAC. And since we know centripetal acceleration is r omega squared, it will be like this. And if we take weight to become mg, now things is coming out, the shape is coming out right now. So we can potong the mass, since it's the same mass we are talking about, and we're looking for omega. So what we can do here is omega square equals to g over r, and since omega square root g over r. Okay, so this is the expression that they are asking for, and slowly by using this equation, Newton's second law, we slowly move until we manipulate until we reach the equation that they are asking for. So for this question, the answer is this one. Omega equals to square root of g over r. Okay, so next question. Oh, by the way, they use radius big R, so technically I should change this to big R. I should change this to big R. I should change this to big R. Okay, little mistake here. Okay, question number 11. Question number 11 involves a small mass being whirled in a horizontal circle at the end of a string. Okay, so you know there will be string connected to a small mass, and it's undergoing uniform circular motion. Okay, and it's on a smooth horizontal surface. Means by this thing is all happening on a surface. Let's say a table. Okay, so you are fixing a string on the center of a table, then you let the ball runs around in circles on the table. Okay, then they say the tension is, the tension should be this way. The tension is T. So when they ask for the tension in the string when the same mass is whirled at twice the speed. Okay, let's be a bit clearer with what the question is saying. Okay, first of all, they ask for tension, new tension. Then they say that the mass of the new situation is the same as the mass of the old situation, and they also say that the velocity of the new situation is 2 times of the old situation. Okay, so knowing these 3 things, we have to use these 3 things to obtain the new tension. Again, any chapter 6 question start with a free body diagram. Okay, let's draw a free body diagram by assuming that the thing is around here. Okay, let's draw a free body diagram here. So when you draw, again, dot, then you have an axis. This axis is away and towards the center of the circle. And then this one you punch through the table, punch through the horizontal surface. So if you draw the free body diagram, you involve the weight, the small mass. It will involve the normal force exerted by the smooth horizontal surface on the small mass, called normal. Then there will be tension pointing towards the center of the circle. Okay, and it's a smooth horizontal surface, therefore there will be no friction, and there's no explicit force being stated. So this is the free body diagram. Now they ask for the tension, and we know tension is, in this case, a centripetal force. It's quite obvious, so let's do it. Sum of Fx is equals to MAC. This thing, the center is here, so we know that it will just be tension equals to MAC. What's along the direction of acceleration, which is T, minus what is opposite the direction towards the center of the circle, away from the center of the circle, which is nothing. So T equals to MAC, and we want to relate it to speed. That's why it's more appropriate for us to change it to mv squared over r. Okay, so this is the relation that we want to find. We want to find tension in terms of speed. Okay, so this is the old situation. Then let's try to do one for the new situation. Let's do n prime v prime squared over r prime. And as we say, n prime is equals to m, v prime is equals to 2v squared. It's the same string, so the r should be the same. Okay, so if we open it up, it will be 4mv squared over r. And this mv squared over r is just tension, old tension. That's why the new tension is equals to 4 times of the old tension. So we can know from here that the answer will be 4t. Okay, so again another ratio question. So by doing the old and the new, finding the ratio between the two things, I'm going to find t new is equals to 4 times of the ot. Okay, question number 17. Last question for this video. What happens to the centripetal force exerted on an object if you triple the velocity? Okay, so they ask for the new centripetal force. Okay, increase how many times, decrease how many times is by comparing with the old centripetal force. So later you probably need to build something like this. Okay, when you triple the velocity, means by the new velocity is 3 times of the old velocity. Okay, so let's start. We know the centripetal force is equals to mv squared over r, and since it's a new situation, we put m prime, v prime, and r prime. The old situation, everything just like usual. Okay, did they say anything changed to the mass? No. Did they say something changed to the velocity? Yes. Did they say something changed to the distance from the center? No. Okay, so we can change it to become m 3v squared divided by r divided by mv squared over r. And from here we can get 9 mv squared over r divided by mv squared over r. Potong, we are left with 9. So the new centripetal force is 9 times of the old centripetal force. And from there, we are able to know that the answer will be this. Increases 9 times. Okay, so that's how you solve question 17, also a ratio question. Find the old situation, find the new situation, get the ratio between them. And from there, you are able to obtain the answer. Okay, so we wrap up the 5 questions for chapter 6 revision quiz. That's all. Thank you.